Alright, so today we are going to be doing our first practical under aerodynamics. So you can go to your VLE and go down, all the way down to the first practical, which is this one, Practical Lab 1, 3D drag coefficient, and click on the worksheet. So you're going to see something like this. Let's open it up and look at what we are supposed to do. So it's a 3D object, and we're determining the drag force. So if you look here, there are several 3D objects drag coefficient lah that you can measure and try. You can either do a cube, a thin circular disc, or maybe a sphere, or in any object that you want. And you can determine what are the CD value lah, which is the drag coefficient. But in this example, we are going to be doing a short cylinder under a horizontal condition. So the cylinder is 200 mm in diameter with a length of 400 mm, and the wind speed is about 90 km per hour. So let's try to do this. You can open up your SolidWorks. At first, we need to model the CAD data. And then we can continue doing the analysis. So you can go to File, click on New, click on a part. And you need to determine a plane lah, which you are going to be drawing the part. So I can choose front plane, right click, click on Sketch. I click on under my Sketch tab, there's a circle here, put it at the center, drag it up, and then put it under Smart Dimension here. So the diameter will be 200 lah. So this is 200 mm because I'm drawing everything in mm lah. So this is my unit. So once this is done, I can exit my sketch and then I can extrude. I'm extruding it blind with a dimension of 400 mm. So this is my part, which is a short cylinder. In order to do flow simulation, you need to go to SolidWorks add-in and click on SolidWorks flow simulation. So you can click it once and wait a few minutes, and it's going to load up this tab, which is flow simulation. So click on it. So you've got your part already here. The easiest way to start doing flow simulation is to click on wizard. Click on wizard. So it will ask you to save the document first lah. So you need to save it, file, save as, put it somewhere, and then click again. Wizard, project 1, click on next. So over here, it's requesting you to choose unit, which is SI. And then down here, you have some more units that you can select. So this is good, SI, and then click on next. Over here, you need to choose external flow. So this is very important. Choose external flow because our flow is in an external condition. We don't have anything else. We don't have radiation. We don't have gravity. We don't even have any rotation lah. Any some sort of fan. We don't have it. Reference axis. Maybe you can choose Z, which is the direction of the flow. Change this one to Z, and then click next. Over here, it's asking you what is the fluid lah. So whether you're using liquid, which is probably water, or maybe you are doing gas, which is probably air. So you can choose lah which one. So we are using gases, and click on air, double click. So gases will be included in your project fluids lah. So the analysis will be laminar and turbulent, so which is okay. You don't have to change anything. This is a pretty good analysis already. So click on next. There is no roughness on your object. It is smooth. And then click on next. And then you are going to put some initial and ambient condition lah, which is velocity in the z direction. So velocity in the z direction, I'm going to put 90 kilometer per hour. So you can put 90 divided by 3.6 lah, which is 25 meter per second. So the velocity will be in the positive z direction. So if you want to change it to the other way around, you can put negative lah. Put a negative value. So this is just the direction of your flow lah. So click on finish. It will come out with a control volume or a computational domain. So this would be your computational domain lah. Since your flow is in the negative z, so the flow will be coming from left to right lah. So you can click on computational domain and change accordingly. Maybe it's a good idea to align it, so you can hit control 8 and then click computational domain again. So since the flow is coming from the left, so the left can be probably this much. However, the right hand side needs to be slightly longer lah, because it's the flow trailing flow lah, which is behind the flow. So drag force calculation is mainly affecting the rear lah. So this much is okay. And then you can click your arrow on your keyboard, rotate it a bit. Looking from the front, it is like this. So this is pretty much okay lah. So this is your wind tunnel. You can enlarge it, wind tunnel size. So other things we can do here, you can always go back to project and right click, and then you can do a few commands here, or you can right click on input data. You can still go back to general settings lah, which is where you have all these things lah: analysis type, fluid type, wall condition, and then your velocity, right? Everything is under input data, general setting. And then we can go to computational domain. This is just the volume. Afterwards, we need to determine the goal lah. In this case, we are determining the drag force. So we need to right click, insert surface goals. So the surface goals would be, you can either click it on your own, click all the surfaces available, or you can easily click Ctrl A on your keyboard. You will select all the available surfaces, and then you need to select force lah. It can either be force Z, or you can just use normal force Z. Let's say I am putting force Z, force Y, and force X. So this would be corresponding to drag force and also lift force lah. Normal force and normal force, this will be the same thing. So this is the surface goal, so the calculation will know lah when to stop. And then I'm going to click OK. So I have all these goals lah. Afterwards, I can click on mesh, right click. I'm going to click on show basic mesh. So this is the basic mesh that I have lah. Right click. If I want to change anything, maybe I can click on global mesh. Currently, the level is at level 3 lah. You can do away with automatic mesh setting by clicking on manual. And then you can do a lot of things lah. You can customize what is the mesh size that you want. but currently we are just using automatic. The more you slide this mesh slider, it's going to become much smaller, the mesh size. Up until 7, so this will be a lot of elements are involved. If you want to see what is the mesh condition, you can click create mesh. It will run. This is just generating the mesh lah. This is running at 7. Level 7. It's taking a long time. So I've got 1 million fluid cells, about 1 million. So this is totally not feasible lah, because it's going to take too long time. So it's advisable for you to just change it back to probably around 3, and then click OK, and then right click, global mesh is 3, so click OK. Create mesh again. Let's see. Just now we were doing 1 million, right? So 1 million will be taking too long time lah. So currently the cell is about 59,000 lah, 59,000 cells. How does it look like? Show basic mesh lah. So this is showing the mesh density. So once you are able to do that, you can just click on run. So make sure you are solving it on a new calculation, run in this computer. Change lah to how many CPUs do you have, and then click on run. The moment you hit run, this will come out, the solver properties. You can monitor a few things here. For example, you can monitor the progress. Click on this button. This will preview you the thing, and you can change to whatever plane you want, maybe right plane, and then click on OK. So you can see what's happening to your model. This is one item for you to do to check the progress. Or you can just click on this one, which is goal plots. Maybe you want to look at X, Y, and Z. Let's take a look at the goal plots. This is showing the goal plots. So most of the force will be involved in the Z direction, which is directly against the flow. So currently the drag force is about 6.2 something Newton. There's not much lift force to up and to the side, 0 something. So Z, which is normal to the direction of the flow. So currently it is still calculating about 55 iterations right now. We just have to wait a few more minutes, and then we're going to be done. All right, we're almost done. Currently it is set at 191 iteration is good already. So you can, this solver window, you can close it. And now we are going to be looking at post-processing, which is results. So click on results. The first thing that you should do is go to flow trajectories. Right click, insert. And then over here you can click Control A on your keyboard. Maybe click one more. And this one. And then change from pipes to arrows. 20, maybe change to 50. This is the width of the arrow. enlarge it a bit, maybe, depends on you, and click on OK. And then you are going to see what is happening on your part lah. So I'm going to change it a bit. It's too big probably. Edit definition 0.1 is good enough. 0.01. Click OK. And then you can right click and then hit play. So you are going to see what's happening to your bluff body lah, which is your cylinder. So the flow comes from the front and then it separates. And then you can see a region behind there where you have a lot of wakes and recirculating happening behind the flow. So your flow is currently doing okay. So you can stop this. You can add a few more things. For example, you can add surface plot, insert, contours, change to pressure. This is good. And then this one you can click use all face. And then click OK. So this will give you pressure plots lah. Pressure plots on your object. If I were to hide this one, click hide. I can see the contours of pressure on my component lah. If I want to make this lighter color, I can click this one, lighting. So it's a lighter color. I can always go back to flow trajectories and then play if I want to see certain things lah. Turn back lighting if it's not so obvious, and then turn it back off if you want. So this is looking at the flow visualization. I'm going to stop this one. So next we are going to put some cut plots. Right click on cut plots, click insert. So currently it is selected to front plane, so you can change this one. Expand here and then maybe choose right plane. I probably want to look at pressure distribution. So I can click OK. So this is looking at pressure distribution lah. Pressure distribution surrounding the object that I have. And I can always expand cut plots, and then I can always play this one. So it will swipe from the left to the right. How is the pressure distribution on the object surrounding? So I can stop this one. So this is a cut plot showing us pressure. If I want to change this one to velocity, I just click on this legend here. Click on pressure, change to velocity, and then click OK. So this is showing you the velocity lah. Over here. So what is the velocity surrounding the object? You can always probe. Click this one, probe. Over here is about 24, 25, 24, 24. However, behind it, it's about 2 meters per second only lah. Over here, it's 14, 23. So you can always determine what are the values on your object. So behind the object where you have recirculation, the velocity is almost stagnant lah. It's about 2 meters per second. You can always play this cut plot also. So red color is about free flow velocity lah, around 25. Alright, I can stop. And finally, the most important thing for you to do is for you to go to goal plots. Right click, click on insert. Obviously, you can look at all, and then you can click show. It's going to be showing you values on all, but the most important one, which is Z direction. So show again, Z direction, and I can always export to Excel. So click on export to Excel. And then I'm going to be looking at this one. So the value is about 6.55 Newton. The negative is fine because it is against the flow lah. The flow is in the Z direction, so the drag force will be opposite lah. 6.55. This is the progression of the analysis where the result flattens, it converges, and this is the raw data. So the value that you should take is average lah. Take 6.55. So this is the drag coefficient of this object, which is cylinder along the parallel along the flow. All right. So next thing that you can do is you can stop this one. Stop. If you want to remove all these values, you're gonna click it and delete. Click and delete. And then we're going to modify lah. So if you want to modify this thing, you can either do a new project or you can save as and do on another project. You can save this one as another file and then do another one, which is the modification lah. So if I were to do the modification, I can always just go to here, click on Feature Manager, and then I can always go to Features. If I want to hide all this data, I gotta go back here lah. Flow simulation is always on this tab. Hide the surface plot. I can hide flow trajectories. I can always have that lah. I'll go to features now. I can click on fillet. This is the fillet here. Maybe I want to change this one to 100 mm and then click on OK. So it's going to show you the geometry of the model has been changed. Do you want to reset the computational domain? You always click no to this one. And then this one you can this is resetting the mesh lah. So this one you have to click yes lah. Cannot find faces associating with this item. Okay, there are some changes that you need to do. Why? Because you have introduced an extra surface here lah. So SG Force X is no longer there. But this one is not really relevant lah. You can delete this one. We are only interested in SG Force Z. So SG Force Z, if you click here, I have one surface missing. Click this one. One surface is missing, right? Because you do some modification. So this one you gotta edit definition, phase 1, phase 2, click one more phase, which is this surface. So if you click on SG Force Z, now you have all the surfaces. And then it's easy because you can just go back to flow simulation and then click run again. Make sure it's a new calculation, so click run. Click on the progress if you want to. The fluid cells have increased a tiny bit, 59,000 previously. I think now it's around 62,000. Takes a while. If your computer is not so fast, you can reduce the number of cells, reduce the number of fluid cells. Change it. Click here to monitor the progress. Click a preview. Front plane change to right plane. Click on OK. This is your progress lah. Okay, so solver is finished. You can turn it off. And then you can always use everything back lah. Flow trajectories, do I need to modify it? Yeah, I can add one more surface lah. Add one more surface here. Click on OK. And then let's take a look. How does it look like? You can see the flow is attached to the surface, and then the flow separates lah behind. And then the rest of the things are the same. Cut plot, show, same. Can change this one to pressure if I want to. Surface plot, show. Make sure I have enough surfaces being selected. Use all face. This one is okay lah. If you click on velocity, it's going to show you 0 lah, because no slip condition. You have to change to pressure. Click on OK. So you can see clearly the pressure location has been reduced a bit. And finally, the most important thing, look at goal plots. Right click, show, edit definition, and click on show. And you're going to see here a significant drop now, which is 3.158. So export again to Excel. It's going to give you about 3.157 lah, compared to previously, which is right, 6.5. So you can do a small modification on your component, which can reduce drag force over 50%. So this is the report that you should do lah. So report you can do, you can plot all these results, plot velocity, pressure, surface pressure. There's no need to do streamlines. Flow trajectories is enough lah. So these 5 things you can plot on your original design and then your modified design lah. So that's all for this week. All right, happy trying.